Assalamualaikum and good everyone. So today we are going to cover the first part of Le Chatelier's principle. So in this video, we are going to have a look at what is Le Chatelier's principle and the first factor that affects the system at equilibrium. Okay, so first let's have a look at Le Chatelier's principle. I think the name is actually pronounced as Le Chatelier because he is a French scientist. Okay, so Le Chatelier principle states that when a chemical system at equilibrium is disturbed, so the system will shift its equilibrium position to reduce the effect of the disturbance. So dia akan shift whether to the right of the system ataupun to the left of the system. Okay, kalau kita kacau sistem tersebut. So kalau kita kacau sistem tersebut, so dia akan try to reduce balik the disturbance so that dia boleh re-achieve the equilibrium. Okay, so sometimes you might see this is the scientist lah, Henry Louis Le Chatelier. Okay, so kadang-kadang kalau tengok buku lain punya definition untuk Le Chatelier's principle, mungkin kamu akan jumpa perkataan net reaction. So net reaction actually refers to the shift in the equilibrium position of the system to either right or to the left. Okay, so kita akan tengok dulu beberapa faktor yang akan affect the system at equilibrium. So it is as follows. The first one is concentration, and then kita akan tengok pressure and volume. So pressure and volume ni together lah, because if kita increasekan the pressure, so volume akan affected by that. Okay, same goes to kalau kita increasekan volume, pressure will be affected by that. So benda ni kita tengok together. And then the third one, kita akan tengok addition of inert gas. And then the last, this is the second last one, temperature. And satu lagi adalah the presence of catalyst. However, for this video, kita cuma akan cover the first one dahulu, concentration. So how exactly concentration affects the system at equilibrium. So for example, we have A plus B producing C and D. Okay, so let's say kita kacau the product, so we add more product. So by adding more product, so the system dia akan shift to the left. Okay, so ini secara general dahulu. Okay, so kalau tak kamu guna apa-apa yang berada depan mata kamu, probably pen, ruler, whatsoever depan kamu. So this is the reactant side, so this is the product part. Okay, so since we increase the concentration of the product, we add more, so kamu tengok dia jatuh ke mana sistem tu. So since the system is going to the left, so system tu akan shift to the left to reach equilibrium semula. Okay, so kalau the next one, let's say kita decrease the product, so this side, right, the product kita kurangkan, so as you can see the system akan move to the right kan. Okay, so dia akan shift to the right. And then now let's say kita kacau pula the reactant, so increase the reactant, so this part is the reactant part, so we add more reactant, therefore the system will shift to the right. Okay, and then kalau kita decreasekan reactant, so decrease reactant, so as you can see the system will move to the left then. Okay, so removing more reactant, kita akan pergi ke pada sebelah kiri. Okay, so please take note that for concentration part, so it will only involve untuk species yang dalam gas and also aqueous phase sahaja. Okay, so no change in equilibrium position if there is any changes in concentration of solid or liquid. So kita abaikan. Maksud kalau kita tambah concentration of a species that is in solid or liquid, you won't see the any net change dekat situ. So no shifting in equilibrium. Okay. Right, so for example, kita ada nitrogen gas dengan hydrogen gas. So I put this aside or else Miss akan sama-sama main dengan itu. So ini dia akan produce ammonia. So this is the QC untuk kita punya sistem ni. So let's say we add more ammonia. So by adding more ammonia, bermaksud kita akan increasekan concentration ammonia kat sini. So now kita punya QC does not equals to KC. So when it is not equals, therefore the system is no more in equilibrium. So initially the system is at equilibrium, but since you add more ammonia, product part, more ammonia, so now system tu dah tak dekat equilibrium, so you have to reduce disturbance ni dan. Okay, so how, apa yang kita nak buat? So apa yang kita akan buat adalah in order untuk reduce balik this particular disturbance, so of course the system nanti dia akan, as you can see, dia akan shift to the left. Okay, so apa sebenarnya yang dia buat? Dia akan consume the additional ammonia yang kamu tambah tadi. So bila dia consume, bermaksud the concentration of ammonia akan berkurang. Okay, tapi what happened to the product? this is the product. So what happened to the reactant? So reactant pula akan bertambah. Okay, so in terms of concentration untuk kita punya nitrogen gas and also hydrogen gas akan bertambah, tapi ammonia sendiri akan berkurang lah. Okay, so kalau kita tengok lagi satu example, so PCl3 reacts with Cl2 producing PCl5. So given to you the QC here, so let's say we add more Cl2, so Cl2 is on the reactant side, so you add more Cl2. So now kita nak try to reduce this particular disturbance then, because kita nak shift balik the equilibrium, right? So the system will shift ke mana then? Okay, so as you can see dia pergi ke kanan. Okay, so QC is not equals to KC anymore. Okay, so how do we reduce the disturbance then? By consuming, okay, dia akan shift to the right by consuming, tadi kita tambah Cl kan, so by consuming Cl. But not only Cl sahaja yang kena consume, don't forget ada PCl3 juga dekat bahagian kita punya reactant. Okay, so consuming additional Cl2 yang kita masukkan at the first place, but at the same time what happened is obviously our product PCl5, since dia pergi to the right, PCl5 sendiri makin meningkat, tapi kita punya PCl3 pula concentration dia akan semakin menurun. Okay, okay, next I think this would be one last example. So PCl3, Cl2, sekali lagi kita guna equation yang sama kat sini, but now kita nak remove PCl3, removing some of kita punya reactant. So removing some of reactant, so again sekali lagi the system now is not in equilibrium anymore. Okay, so the QC does not equals to KC, so what's gonna happen here is, as you can see, the system will shift to the left. Okay, so what's gonna happen to yang lain dan? Okay, kita punya produk ataupun reactant yang lain. So what's gonna happen here is the PCl3 and Cl2 dia akan increase. Okay, this part dia akan increase. Tapi what happen to kita punya produk PCl5? PCl5 pula akan decrease. Okay, so that's itu yang berlaku lah bila kita kacau sistem sebenarnya. So dia akan affect the some of the concentration of other species. Okay, so you can have a look at this. So this is basically a summary of what happened to each species yang ada dalam kita punya reaction tersebut kalau dia adalah gas ataupun aqueous solution. Okay, so this is kalau kita kacau hydrogen. Okay, so hydrogen is added to the system, bermaksud concentration of H2 akan increase. Therefore kita akan try to reduce dia punya concentration, so kita mesti consume balik yang hydrogen gas yang kita tambah tu tadi, and then dia akan produce more product lah. So the system dia akan shift to the right in order to decreasekan the concentration of H2. So what's going to happen adalah concentration of the product itself akan increase, meanwhile concentration of kita punya both reactants akan berkurang. Okay, so you can read this on your own. Okay, so yang ni pula kalau dia remove H2 from the system, so what's going to happen. And then the next slide kamu akan boleh nampak pula kalau dia kacau produk pula. Okay, so kalau dia kacau produk, yang ni dia akan increasekan concentration product pula. So what's going to happen? So where the system akan shift pula. Okay, so obviously this one dia shift to the left, meaning less product is produced, meanwhile kita more reactant is produced dan concentration dia akan increase. Okay, right, so have a try untuk try this 20.0 ni. So boleh try terus. Okay, so jawapan Miss akan keluarkan lepas ni. So pause kejap video ni. So buat dulu, try jawab soalan ni, and then Miss akan reveal the answer. Okay, pause dulu. Okay, kita continue dengan harapan kamu pause lah tadi video tu. Okay, so kita continue. So you can see the answer here. Okay, I will explain this in the class later on kalau tak faham, but hopefully kamu faham kenapa jawapan macam ni lah. Okay, and then try buat juga yang try this 21 ni. Okay, try this 21. So give it a try dulu, pause dulu video ni. Lepas dah pause, lepas dah jawab semua soalan, and only then kamu proceed balik. Okay, Miss harap kamu dah pause tadi. So now kita continue. So the answer for kita punya try this 21 ni, A increases, B decreases, C increases, D unchanged. So Miss harap kamu boleh jawab dengan betul yang ni lah. Okay, so we'll end the video here. So we will discuss on this try this question if needed. Okay.